Wow! Japanese scientists have just revealed the secret of teleportation. And this is not science fiction, but reality. Imagine, in the morning you wake up at home in New York, and a second later you are already sunbathing on a beach in the Maldives. No airplanes, no traffic jams, no waiting at the airport. Just one step into a teleport, and you are in any place on the planet. Think how much money you would save on plane tickets. You could have breakfast at home and then lunch in Paris. Scientists are sure that soon this may become reality. For now, the Japanese team from Kyoto and Hiroshima universities have only fully figured it out with 3 particles of light, smaller than an atom, and something incredible happened. This information was transmitted instantly, as if distance did not exist at all, much faster than the speed of light, faster than anything we knew before. And the most important part, the Japanese solved a problem that scientists had been fighting with for 25 years. They found a way to work not just with pairs of particles, like before, but with bigger groups. And this changes everything. Because if you can teleport 3 particles at once, then you can teleport 30, 300, or 3 million. Which means that from teleporting microscopic particles to teleporting whole objects, it is only a matter of time. And it all began in 1935. That was when Einstein said, "This is impossible." He did not believe that particles could instantly affect each other at a distance. The brilliant scientist called it spooky action at a distance. Einstein was sure that his theory of relativity forbids the transfer of information faster than light. But his colleagues Podolsky and Rosen came up with a clever thought experiment. They showed, what if Einstein was wrong? What if particles really can instantly sense each other? Einstein refused to believe it until his death. Years passed. In 1964, the physicist John Bell found a way to test who was right, Einstein or his opponents. Bell invented a real experiment that could give a final answer. In the 1980s, scientists finally carried out this experiment. The result shocked everyone. The great Einstein was wrong. It turned out that 2 particles really can be connected by an invisible thread. If one changes, the other feels it instantly. It does not matter if they are separated by centimeters or by light years. The 1990s changed everything. Scientists realized that this strange connection could be used. If particles feel each other instantly, then it means information can be sent faster than anything in the world. Not by moving the particle itself, but by copying its state in another place. Scientists called this quantum teleportation. 1997, the first real teleportation, the team of Austrian physicist Anton Zeilinger teleported the state of a photon. Distance, just a few centimeters in the lab. A tiny step, but it was a real breakthrough. The whole world talked about it. 2002, they teleported not just one particle, but an entire laser beam, as if they learned how to move not a single drop, but a whole stream of light. 2006, something unbelievable happened. Scientists took a laser beam, teleported it into a cloud of atoms, and then turned it back into light again. Like magic. Light became matter, and then matter became light again. 2012, a breakthrough. A particle was teleported across an entire city. Several kilometers were crossed instantly. Distance was no longer a barrier. 2016, the Chinese launched the satellite Missions, the first space teleportation laboratory in history. 2020, the Chinese did the impossible. They teleported particles directly from space down to Earth, hundreds of kilometers through the void, instantly. Space was no longer a limit for teleportation, but that was only the beginning. February 2025, scientists from Oxford in Britain made a real breakthrough in science. They linked 2 quantum computers with teleportation over a distance of 2 meters. Quantum computers are special machines that work by the laws of quantum physics. They are millions of times more powerful than normal computers, but very fragile. And now the British team learned how to connect them with teleportation, like with invisible wires. Not just particles, but entire computing operations were transmitted between them instantly. The world thought, that's it, the British are the first. But Japan was preparing a surprise. September 2025, the Japanese did what had seemed impossible for 25 years. They learned how to teleport not just one particle, but a group of several particles at once. The British showed that teleportation works between computers. The Japanese found the key to scaling, how to move from single particles to groups, and that means to complex objects. Until now, all experiments were like a dance of two partners. The British showed a practical step. They connected quantum computers with teleportation without any wires. But Japan went further. They managed to make an entire group of particles dance. This was no longer a duet, but a whole ensemble. For science, it is like moving from table tennis to football, or from connecting two computers with a cable to creating the worldwide internet. Why is this so important? Because working with groups of particles opens the path to scaling. If you learn how to control groups of 3, 10s, and hundreds, then you can teleport not only bits of information, but whole blocks, complex systems. Today, scientists teleport particles of light, tomorrow of molecules, the day after tomorrow, whole objects. For 25 years, scientists knew it was possible, but they could not do it. The Japanese built a device able to catch what had escaped researchers for decades. But all these discoveries are only the first theoretical step. Real teleportation requires technologies that are now being built by the giants. Google released the Willow chip with 105 qubits. These are quantum bits, the foundation of a quantum computer. This chip completes calculations in 5 minutes that would take a classical supercomputer more time than the universe has existed. IBM promises that by 2029, it will create the Starling quantum computer with 200 logical qubits, able to perform 100 million operations. Microsoft developed a new type of topological qubits called Majorana 1, which can be scaled up to 1 million qubits on a single chip. And in April 2025, the University of Illinois reached teleportation accuracy of 94%. Almost perfect transfer of quantum information. This means teleportation is becoming not just an experiment, but a reliable technology. Even now, quantum computers are starting to solve real tasks. In March 2025, the company IonQ used a 36-qubit computer to simulate a medical device, a blood pump. The result? The quantum computer was 12% faster than a classical supercomputer. This was the first time a quantum machine beat a normal computer in a real engineering task. The quantum industry is growing fast. In 2024, companies earned $750 million, and in 2025, the number is expected to pass 1 billion. The UN declared 2025 the International Year of Quantum Science. The world is preparing for a quantum revolution, and the more powerful quantum computers become, the more complex objects they will be able to teleport. Every new qubit, every improvement in stability and accuracy is a step toward teleporting not only particles of light, but also whole molecules, cells, and later objects. And what comes next? In the next 5 years, scientists will teleport simple molecules over hundreds of kilometers. Imagine, a part in your computer breaks. It will be replaced instantly without opening the case. You are sick? The medicine will be teleported directly into your body. A doctor in London teleports a rare drug to a patient in a remote village in Africa in seconds. The problems of delivering rare medicine to faraway places will disappear. But this is only the beginning. Imagine a world without warehouses. A factory in China produces a part, and it instantly appears in a factory in Germany. Oil from Saudi Arabia is teleported directly to Indian refineries. Gold from African mines appears in Swiss banks instantly. No tankers, no trucks, no trains. The space program will change forever. Why spend millions on launching a rocket with cargo if building materials can be teleported directly to Mars? Astronauts will receive fresh food, oxygen, and water instantly from Earth. In 10 to 20 years, teleportation of complex molecules, maybe even cells, across continents will be possible. Doctors will teleport healthy cells to a cancer patient. Ready space modules and scientific equipment will go to space without rockets. Farmers will send seeds of elite crops to any point on the planet instantly. Archaeologists will teleport valuable finds from dangerous zones into safe museums. In 20 to 50 years, teleportation of small objects, maybe even simple organisms. At the same time, a global instant transfer network will become available to everyone. Teleports will appear in every home, like Wi-Fi routers today. Forget about delivery. Your order will appear in your house instantly. You order an iPhone from the Apple Store. It materializes on your table in seconds. You want sushi from the best restaurant in Tokyo. They appear in your kitchen hot and fresh. You need a rare flower for a bouquet. It teleports from any corner of the world. Pets will be able to travel to the vet instantly. Plants from exotic countries will appear in your garden in seconds. Ordinary people will gain access to a technology that will change the life of every family. Teleportation will stop being the privilege of corporations and governments. It will become as common as ordering food through an app. Emergency services will change completely. Firefighters will teleport water directly into the heart of a fire. Rescuers will instantly deliver oxygen under rubble. Police will teleport evidence from a crime scene directly into the lab. The main question, what about people? Here there are problems. Every person is made of trillions of particles. A model of human teleportation would look like this. Every particle of the body is measured in one place. The information is sent to another place. There an exact copy appears, and the original body is destroyed. Visually, this is teleportation. You disappear in one place, a copy appears in another. But the moment of destruction is frightening. Memories, thinking, feelings. Are they all inside the particles? And what about the soul? The copy may appear in another place, but will it be the real person? Where is the guarantee that some part will not be lost? In 30 years, we went from centimeters to cosmic distances, from one particle to large groups of particles. The Japanese and the British this year showed two key pieces of the puzzle. The next step, molecules, then objects, and maybe even people. The only question is, who will dare to be the first teleported human, knowing that the original will disappear forever?